Hello everyone. Today I will talk about structural performance of reciprocal structures formed by using Islamic geometrical patterns. So let's look at what is reciprocal frame structures first. Reciprocal frame structures consist of mutually supported rigid elements. The module in reciprocal frame structure is a short piece of the whole structure. Reciprocal frame structure have many advantages. Large openings can be covered via bringing together a large number of short pieces. Therefore, reciprocal frame structures are also known as one of the structure types used to create large span in buildings. It can be also suitable for emergency situations since it can be built quickly with local materials. So in the slide, you can see some early examples of reciprocal frame structures. And at the lower part of the slide, you can see some contemporary examples of reciprocal frame structures. And we saw that there is a potential in Islamic geometric patterns to be a reciprocal frame structure. In this study, it has been determined that Islamic geometrical patterns with polygonal systems and reciprocal frame structures are constructed with the same principles. In both systems, the pieces of the patterns symmetrically overlap each other. Two-dimensional Islamic geometrical patterns are mathematically defined patterns. It can be easily seen that some of these two-dimensional patterns have overlaps that give a sense of three-dimensionality. Three-dimensionality in Islamic patterns is in the form of overlapping. The overlaps are defined in a very regular and systematic way. To understand this order, we can consider one of the strips that forms stars in the Islamic pattern. If a strip passes under the next strip, it will pass over another strip in the next encounter. This system repeats and a network-like tessellation is formed. Schneider has clearly described this situation in the drawings of Islamic geometric patterns in his book. In the drawing, like in the screen, although a pattern was created with a single line placed. Schneider made the system in the pattern understandable by showing the lines passing under the other lines with a dashed line. When we consider the patterns in three dimensions, we can easily say that the patterns consist of many pieces. The systematic formation of many pieces by overlapping is similar to the principle of forming a reciprocal frame structure. So in this study, 6-pointed star polygon pattern calculation in Schneider's book was used in lifting Islamic geometric patterns to the third dimension and transforming them into a reciprocal frame structure. In the study, a pattern with 7 units, a pattern with 19 units, and a pattern with 37 units have been created. After creating three-dimensional models in Grasshopper, structural performance analysis of the models were made using Caramba. Comparisons of the model structures were made by using different materials, timber, steel, and concrete, and different number of supports were used in order to see structural performance difference. So let's look at the pattern with 7 units. The pattern with 7 units is 2 meters in diameter. In the test for the pattern with 7 units, it can be seen that there's a little displacement value in all results. In all the tests, it was seen that steel showed less displacement value than the other materials. In the analysis where the material is kept constant in the test and the number of supports is used as a variable, we naturally see that the maximum displacement result increases as the number of supports decreases. The next test with 19 units pattern. This pattern is 390 centimeters in diameter. It was seen that steel showed less displacement value than the other materials. The results of the maximum compression, maximum tension, maximum moment, and maximum shear were the lowest in the timber systems. The larger diameter of the model gives larger the maximum displacement value. As the dimension of the cross-section increases, the maximum displacement value decreases. The last test with 37 units pattern. This pattern is 582 centimeters in diameter. It was seen that still showed less displacement value than the other materials again. The results of the maximum compression, maximum tension, maximum moment, and maximum shear were the lowest in the timber systems. The larger the diameter of the model gives the maximum displacement value. As the dimension of the cross-section increases, the maximum displacement value decreases. So as a conclusion, we saw that we observed that the created system has a dome-like shape. When the system was enlarged with the increasing unit, it was observed that the maximum displacement values in the system normally increase. It was also seen that steel showed less displacement value than the other used materials in every test. In each test, the results of the maximum compression, maximum tension, maximum moment, and maximum shear were found to be lowest in the timber system. Yes, we can say that there are many similar types, more complex or more simple Islamic geometrical patterns in literature. Similar studies can be performed using various Islamic geometrical patterns. Thus, new ones can be added to the reciprocal frame structure morphology. Thank you.